Hi YouTubers. This is our first attempt at what I call a wet circuit. A simple circuit, and I'm using an LED as E-load. It's rated at about 5 watts. And constant current study, 240 with this power supply, constant current, 3.57, 3.58 volts. Now, what is in that AA container, if you can see it, let me zoom in. What's in there? I have run this for a week. Graphite twine, not treated with oxidizing agents or sonication, commercial graphite twine. The resistance of it per centimeter is only about 5 or 7 ohms, so it's pretty conductive. And I've run this for about a week, as high as 680 milliamp constant current, and that was corresponding to about 5.07 volts. So it ran more than a week, day and night. And then I shut it off, wrapped the graphite in a very thin paper. It's actually paper used for chromatography, and I'll put down the source. And these are AA sized containers. I get them on eBay or Amazon. You can find them on Amazon. I checked last week. And the graphite twine is wrapped in the paper. Now, this is now a wet circuit, as I define it. The paper contains about 1 milliliter of a classic deep eutectic solvent, and it's choline chloride and urea. I'll put the exact stoichiometry we used, and the paper has been contacted in the graphite with this as an electrolyte solvent. And we're going to run this for about a week, and we want to see if there's going to be any problems with resistance or what have you. So we're running it. What's nice here is, let me get back in there, we're running at 3.58 volts. Now, most supercaps, commercial supercaps with organic electrolytes, organic solvents, let's say, like dimethylformamide, you don't go really much above in the industry 2.7 volts because of flammability. So we're trying out this wet circuit. Wet meaning the graphite material, in this case the twine, has been contacted with a deep eutectic solvent. Not exactly the same as an ionic liquid, but very similar in some regards. And then we're going to follow it up with a run where we will place in the ionic liquid lithium tetrafluoroborate electrolyte, which is readily soluble in this deep eutectic solvent. So the dry circuit only had the graphite. And here, the wet circuit, as I defined it, has this deep eutectic solvent. And the rationale is we're hoping that we can have supercaps of this type where you can go up to 3.5 volts. And to be able to pull out a 1/4 of an amp would be have applications for certain. I'll upload the mass of the cradle, the AA, the graphite, the paper, the solvent. It's about somewhere around 8 or 9 grams, but I'll record how much we're using. And I want to see after a week if any changes take place here. And there's a pinhole in the cradle, but I don't expect any sizable vapor pressure of this deep eutectic solvent. Thank you for watching, and we'll keep you posted on results. Bye for now.